introducing it today. Okay, so here we go. Time. My sense is we've already discussed adventure, but I would have liked you to have been making API calls by now, which is not to call out anyone that's not that far yet, right? That's totally fine. And then there's also advising ongoing. So far, most of the advising emails I've gotten are of the form, I have ignored every email you've sent for the last 3 weeks and now I'm panicked. That is not my problem. But if that's not you, if it's like, I have read all of the emails you have sent for the past few weeks, and I even attend class, which is something that not everyone does, then I am happy to help you, right? So if you are here right now, you get the concierge advising if you get a problem, right? Obviously, all students are my favorite, but the students in this classroom right now are definitely my favorite, right? Okay. This is more relevant as we go into break. So, like, some people have these things called families that they spend time with over the holidays, right? That might be you. That might be me. No one has any real way of knowing. But sometimes that means that you, like, wake up in a cold sweat on, like, a federal bank holiday, and you're like, oh no, I didn't sign up for Chemistry 116 Gen Chemistry 2, and I don't know what to do. Just send that little email right then, right at 3 a.m. on the federal bank holiday, and as soon as it hits my inbox, it's not your problem anymore. And then go back to hitting the honk shoe me angles. Just go, right? And so do that over break. All right. Today, computer science as an experimental science, and this is write good code relevant. This is a follow-up to the binary search lecture from the old last class, and this is the code we worked on last class. So let's go ahead and take a look at this. I think I can get this all to run again. So I have the old VS Code here, which I was using that to do some web development. Oh, by the way, okay, cancel. This is the solution to the get valid choice milestone. So ask me about that after class if you still have questions. It's not particularly relevant to what we're doing right now. What were we doing right now? File. Okay, we're gonna make a new. Wait, trying. Install. Post. Rec. X. Okay, we're gonna just make a new Python file. We're gonna call it new file.py. And what are we going to do in that file? See, do I have, okay, I have the English dictionary right here, so this should be not too bad. So we're going to take this code. This code checks to see if a word is in the English language, or it's checked to see if this word is in some word list, which is a very fun thing to do. Do you all remember doing that last time? You remember the peanuts? Remember in the grinders? Yeah, okay. Not like a Subway grinder, like a coffee grinder, like a conical bird grinder. And so in order to get this to work, I also need to find English words, which I'm pretty sure, okay, let's see if I can remember how to do this. We're going to import JSON, right? Does that sound right? Don't let me fly solo here if I do something sillier than normal. I think I'm going to say JSON.load, and then I'm going to give it no, not a file name. It needs a string, so I have to open the file. Okay, the file's name is eng.json. That doesn't work because this thing is a file, is the description of a file, and we need to get the text out of it, so we're going to read it. Okay, and then we're going to print English words. We're going to print the first 10. This is totally going to work, I think. Nope. Folks, we didn't do it. How do we usually do this? Let's see. JSON? Oh no, that's different. Okay, that's not helping. Is it JSON.loads? Okay, you just have to put an S there. Could have fooled me. Which raises the question, can I just put a file there? Oh my gosh! Okay, do you see that? Okay.
Yeah.
All right. This is... I am not going to use that word. I'm going to say it's ludicrous.
Okay.
All right. Okay. So JSON.load, you just give it the file. JSON.load with an S, you give it the string that you get from the file by reading it. Those two lines do the same thing. I'm happy about that. Yay! Yeah, this is sparking joy. Okay. If it doesn't spark joy, I was gonna say go to Mordor and throw it into Mount Doom, which is kind of the same thing. All right, let's check to see if some words are in English. Anyone have a word that they're not sure is a word? Snazberry. This one always gets me. I think it was in a Seuss book. Not sure if it's a word or not. Only one way to find out. You hit it with the old, well, let's print out the word. And then we're going to check the word. We're not going to keck the word. We're going to check the word. And the word is going to be word. And the word list is going to be English words. Okay? Ooh, snazberry. Not a word. What about the closely related raspberry? What if we spell it the same way? Wait. So maybe that means the snazberry is spelled this way. No, that's not true. Okay. All right. So we're successfully checking English words. I hope this suffices for a review to get us back on our feet. Here is the whole file so far. You'll see that it helpfully fits exactly in one screen. And also all of the code is on the slides. Okay. So this is where we left off with binary search. Okay. Up next, what do we have? Well, this is algorithmically efficient. And I will, at the end of class, demonstrate to you that it is relatively algorithmically efficient. But not to worry, we are today going to discover a new type of inefficiency. Remember how last time we discovered a new way of being wrong? Now we've discovered a new way of being slow, right? So previously we were slow and wrong, but in ways we hadn't discovered yet. So this is technically inefficient in that the algorithm makes sense, but the technique leaves some things desired. So this is like if you do a front side 1080, but you're like not wearing a sick fit, right? Is that, the kids skate still, right?
Yeah.
Yeah, okay. I also skate. Actually, specifically, I saw a bumper sticker once that said skate or don't, and I don'ted. Okay, let's look at, in particular, these two lines. And where did I extract these lines from? They are in the if statement. Okay, so I've got my word list, and I'm creating a new word list. And so each time I go through my loop, I take the old word list, I take half of the word list, and I make that my new word list. Okay? And so I am creating additional stuff that's going to float around in the program. And I can do a quick example of this. I'm going to add a few print statements to this and take a look at what I'm doing. Okay, so I have a while loop here. This while loop's going to loop many times. And all I'm going to do is I'm going to print the ID of the word list each time. And when I do this, we'll see that these numbers are changing, and they're changing many times. So I'm creating many different word lists. And some of these are big, right? This file right here is 1.5 megabytes, and VS Code doesn't want to load the entire thing. Okay? And the first time, and so that's this thing, and the second word list is going to be exactly half that size, so this thing is still 0.75 megabytes, right? And then it gets smaller, but I'm sort of taking up a lot of space physically within the computer. So let's solve that problem, or at least let's study it. By the way, if you are following along and you do not have English words, apparently this technique will work to get it. if you're all into that or not, but if you didn't have ing.json on your computer. I am going to precisely measure how big English words is. I showed you how big ing.json was. It might be a little bit smaller inside of Python, and in fact, this slide suggests it was on my old device. But in Python, I can do this thing where I import sys, and sys is another module. It is like JSON, and I can use sys to check the size of something. So I'm going to use sys.get size of, get size of, and I'm going to get the size of, I'm not going to put English words in quotes. I was going to put it in quotes. Well, okay, let's put it in quotes. Oh, it's little. Oh, I'm not printing it. Oh, okay, it's like, so that's of size 54, right? Legitimately no idea how that thing is of size 54. Would not have guessed that. Would have guessed it was the number of characters. I would have guessed it's the same as length. So what do I know? Absolutely nothing. That's not true. I know that I know nothing. So I know
one thing.
Oh, but the thing I knew was that I know nothing, so I falsified it.
If you know the set containing the empty set is still a set of size 1.
The set containing the, yes, but the empty set is not in the set of size 1.
This is true.
Yeah. Let's go ahead and hit it with a size of English words. But wait, okay, hold on. So if the empty set is of size 0, and the natural numbers are the numbers we use to count things, that would mean that 0 is a natural number. You can tell the mathematicians aren't paying attention because I just said 0 is a natural number and none of them freaked out. Okay. Which it is. Okay. So anyways, this thing is large. It is of size more than 1 million. That is 1 followed by 6 digits, right? So that is more than 1 million in size. 1 million letters or 1 million bytes. It's a megabyte in size. Okay. So each time we cut this in half, it's costing us, we can assume like up to the cost of a megabyte, right? This should not feel like a lot to you. Modern computers can deal with megabytes, no problem. If you turned in this code in 1974, you would get fired out of a cannon into the sun. That's a true story. My undergraduate advisor has actually stood on the surface of the sun. Yes, this was Professor Manhattan, formerly known as Dr. Manhattan, one of the Watchmen. Any Zack Schneider? Wait, no, was Watchmen Zack Schneider? Anyways, we're going to stop talking about comics. And so so rather than doing things the wrong way, the algorithmically efficient, technically correct way that is technically inefficient, right? We're going to do things in the way that is not only technically correct, that is not only algorithmically correct, it is also going to be technically efficient. And the way we're going to do that is we're only going to have one word list we work with, and instead of making copies of that word list, we're going to keep track of where we are in the word list. So I'm going to search between a location I'm going to call head and tail, and let's just write this out. So I'm going to say head is 0. So when I first take a look at my word list, I know that if my word is in the word list, it is at index 0 or later. When I first look at my word list, I know that if my word is in my word list, it is at position length of word list -1 or earlier. So it must be in here somewhere. And I know that in the middle of those two things is, and a lot of people don't know how to spell middle, but it's M-I-D-L. That's a fun fact. I know you don't believe me, so I'm going to show you that middle is in English words. Okay, so English words is wrong about this. Oh, wait, no, they probably have the archaic spelling. Okay, there we go. They have the archaic spelling. And so, what do we have here? Middle is going to be tail minus head divided by 2. What is that? That's the distance between the two places that the word could be contained within. I'm going to look halfway between them. And I'm going to see if my word is in the first half or second half. Actually, we can put middle in here. Let's see. Let's see, that's half length. That's what we're getting rid of. Okay. Word list middle. Okay. So I'm going to check to see if my word is before the word that is in the middle of the current part of the word list I'm working with, in between head and tail. If it is before that, then that means I only need to keep the first half of the word list. So I'm going to say the tail is going to be equal to the middle. I know I can do this because I know I have checked that the word must be after the head and it must be before the middle. If the word is, I need to put something, we'll just put true here for now. Okay. And if my word is after the word in the middle, well, then that means that we can start searching with the head equal to the middle of the word list, and then we can loop again. Okay? So, then what are we going to do? Then we're going to recalculate the middle. Okay. This is going to work pretty well. So, this, by the way, that is the distance between, or that is how far from the head the middle is, because that is the distance between the head and the tail divided by 2. To do that relative to the head location, we also have to add head to it. So I'm going to do that. Now I'm going to move some of this stuff around. I can calculate this middle location after I've calculated the tail and head. I need to calculate it outside of the list once. And then let's see. I think I need to say, well, tail minus head greater than 0? I don't know. Then I put middle here. How does that work? That seems to be an infinite loop, probably. Do you see how that might be an infinite loop because the code is still running? It's still going. It probably would have found it by now. Okay, so let's go ahead and let's go ahead and try and fix this somehow. Okay, I know I didn't want to fix it either. And an obvious way to fix this is to print. No, I'm gonna input. Y'all know about input, right? So input's how you like read text into things. It's a little bit useful on Adventure, right? And if you put text inside of the input, it prints that out. All right. So what am I going to do? I'm going to print head, middle, tail. Okay. And then when I run this, oh no, expected. Oh, that's so annoying. It has to be a string. I don't really want to do a string. And this is going to all just smoosh them together. That's annoying. Do y'all know about format strings? Did I teach you that? You know? Okay, we know about format strings. Okay, I'm gonna do a format string. Don't freak out. Okay, it's fine. I think it's something like. Does this seem like?
Yeah.
It's different in every programming language. In case you're wondering why I'm so scared to do this in front of people, and it is like slightly different. No, oh, that worked. Okay. All right. So, what happened here? I don't know, something cool, probably. I should put that at the end. Well, okay. We're going to put this at the beginning of the loop. Okay. So, the first time I enter the loop, I have about this many words. This word is in the middle, and 0 is, I don't know, the beginning. Since this is waiting for input, it's not going to do anything with the input. When I press enter, it's going to run the loop again, and it's going to look in the second half of the alphabet. And that's interesting because word is middle. I guess middle is after the middle of the alphabet or something, right? And so now I'm looking in between the 6,000th word and the 63,000th word and the 127,000th word. And I'm going to check to see if it's before or after the 95,000th word. I'm guessing I'm going to end up in between these two this time. And I did, so now I'm looking in between the 63,000th word and the 95,000th word. And we can do this, and we can see we sort of steadily hone in on a location closer to wherever this word will ultimately be. We're getting closer and closer, we're getting closer and closer. And look how close these numbers are getting together, right? We're now only looking at like 5 words at a time or something, right? Okay. And then where's the infinite loop happens? It happens right here, where head and tail never get exactly to each other. They're always one apart. No problem. This was supposed to be 1. We're going to comment this out. And then we can find that middle is in the dictionary. We can probably put maybe a snazberry in there. Okay, snazberry's not. Raspberry? Raspberry is. I'm going to hit it with the flotilla. Anyone got any other words they like? I'm a big fan of canopy. Any words? Banana? Xylophone? I'm coming up with all the words here myself. I feel like I'm the only one working hard today. Shenanigan? I don't know how to spell that.
Banana.
I already did banana.
Oh, you did?
Yes.
Oh.
That's why you thought of it. You're suggestible.
Let's do strawberry.
Computer.
Let's see if there's a computer in the computer. Let's see if the computer contains intelligence. Wait, how do you... Oh my gosh! Oh! It's artificial... Sorry, I can stop. I wonder if the computer has feelings. Oh, it has 1. Oh, it has 2! I wonder if it understands love and beauty. Folks, yeah, I don't even know what humans are for anymore. We've been completely replaced. Okay. So this is Can I just say that this is pretty cool? Is that, can we, well, we can all agree this is pretty cool, right?
This is pretty cool.
Okay, it's pretty cool. It's maybe not like the coolest. Maybe it's the coolest. It's pretty cool. All right, let's try and fit this all on screen. There we go. There we have it. Okay. And so, now, what are we going to do with all of this? Well, I told you this is better than the other thing. And why would you believe me? I'm a registered lobbyist with big computer science. I'm trying to trick impressionable youths into taking computer science classes even when they don't want to. And so you should be suspicious of everything I say about code being good or bad, right? So I'm going to prove it to you. And the way I'm going to prove it to you is we're going to check how fast things are. We're going to use Python in. We're going to use the naive for loop technique where we just loop over every word and see if it's the word we're looking for. We're going to use the version from last class, and then we're going to use the version from this class, and we're going to see how fast they are. Now, there is more to life than writing fast code, right? Like, things being fast doesn't mean they're better. But have you ever seen someone go to a car dealership and say, no, I don't want that car, it goes too fast, right? Never happened, right? And have you ever been playing Grand Theft Auto 5? That was a trick. Never admit you've been playing Grand Theft Auto. Okay, all right. So we're gonna go fast because going fast is cooler than going slow. Okay, is it my fault it's cooler? No, it just is, right? Okay, so yeah, because that person on average is going the fastest.
Yeah, I guess that is kind of the point of the story.
Yeah, you're not supposed to go out too fast, or your coach will yell at you. You're supposed to stay in zone 2 heart rate the whole time. Okay. Okay. So I did a like trail fun run this weekend where easy miles pace was encouraged. Folks, I checked my watch after that, and I ran a 7-minute mile, which I've never done before. I don't think they were going easy. I think they were trying to trick me into having a heart attack. Anyways, I lived. Wrecked. Okay, so, you probably have all heard of the epoch.
Yeah.
It began in January 1st, 1970 in the British Isles because it's based on Greenwich Mean Time. And that's because the British colonized everything. And is that bad?
Yeah.
Yes, correct, yes. Yes, the British are bad, right? The Americans are bad because they're based on the British, right? It's like, okay.
For some other reason as well.
Yeah, they've like done enough on their own, right? But really, it's what you would expect from a former British colony, right? So, anyways, let me show you how time works. And I think I'm gonna indulge myself a little bit. We're gonna go just a little bit terminal style here. We're gonna walk over to the terminal. We're gonna embiggenify it. We're gonna hit it with the old clear. So in the terminal, fun fact, I know you all love using the terminal, that's why I like to show it to you all of the time. You can type Python 3, and then you can do just this little -c here, just a little -c, not a big one, not a capital C, right? That's me. This is compact disk, right? Okay, and that stands for command. And then you can open some quotes, right? Just some little quotes. I like the double quotes. Some people like the single quotes. And you can put code inside of those quotes. So you can hit them with the old print hello. And I know what you're thinking. You're thinking, there's absolutely no way you can put double quotes inside of double quotes. And you're right. That's true. Why am I doing this here? Okay. So that's a little bit against the law. But you can put the single quotes inside the double quotes. Remember when we learned about the different quotes you can use to make strings?
Yeah.
You need single quotes or double quotes, and you can do that specifically so you can get up to this kind of nonsense, right? Now, I'm going to introduce just a little thing. I'm going to import time. That's all I'm going to do, okay? And I know what you're thinking. You're thinking, oh no, how are you going to write multiple lines of code inside quotes? Folks, you can put semicolons in the place of new lines in all of your code. Watch this. Semicolon, right? It works. Okay, but we're still not looking at time, right? Okay, let's just take a look at time real quick. It's a built-in module, and in that way, it's going to be the same as something like JSON, probably. Okay. All right, not too bad. Apparently, those are different things. I don't know. And then what can we do inside time? Well, we can look at the time. So I'm going to go inside time. I'm going to ask it what time it is, right? Did I name these? No. Who does that? It's time.time, and it works because obviously this is the number of seconds since January 1st, 1970 at Greenwich Mean Time in the British Isle, right? You don't believe me? Wait 1 second. Wait 1 second. Wait 1 second. Oh, that was 2 seconds. Wait 1 second. Wait 1 second. See how it's going up by approximately 1 every second?
Whoa.
Yeah. That's what's known as going terminal style. Okay, so now that we've finished terminating, do people still know about the hit film Terminator?
Yes.
Okay. I still associate the Terminator with the area on the surface of the Earth where night is beginning. That's referred to as. Have you all heard of this?
No, I haven't.
Terminator Earth Science. Let's see if we can get it. Let's do we trust the AI overview?
No.
You can if you want. Okay, this is the Terminator. How much cooler is that than a bodybuilder? There's nothing wrong with bodybuilding, right? But that's not even sick. That's ill, right? That is down with the sickness. Okay. A moving line that divides the daylit side from the night side of a planetary body. Right? Who ruined that by making it a robot? This is so much cooler than robots. Okay.
At dawn and dusk, you're in the Terminator.
I don't think you are at dawn. I think it's something else at dawn.
Okay.
Because this is only between the daylit side and it.
Well, it's the same.
Oh, do we think so?
It doesn't, the line goes all the way around.
It does go all the way
It's just a
around.
circle.
Is the whole thing the Terminator?
It's alternative.
Wait, why are the only two authority-controlled databases the United States and Israel? Get me out. I'm not canceling class over that one, but I thought about it. Okay, okay. I'm fine. You all fine? Y'all hanging in there? Okay. Let's do a cute little demonstration. What do you say? Who loves demonstrations? I'm gonna leave my code in here, but I imported time. I'm gonna yoink this whole thing. I'm gonna hit it with a little yoink style. Am I? All right. Oh, this one says just time. Yeah, we're gonna say time dot time. There we go. That's a little better. All right. After you press enter, the amount of time since this text appeared will be printed. Really? I guess it was 7 seconds. That was under a second. Okay. Someone needs to tell me when.
When?
I was too far away. Should we do it again?
Yeah.
You're all cowards.
Oh, I said it already. I don't want you to feel
Yeah, you're not allowed to say it again.
Yeah, exactly.
If you say it, I won't listen.
Yeah, okay, go for it.
You have to say when.
When?
Okay. If that felt like an eternity to you, that was only 18 seconds, by the way. Okay. So what else can we do for this? Haha. Have I got a fun thing that we can do? Y'all know about words? Like, for example, raspberry, which is named after the Raspberry Pi microcontroller. We can, wait, why does that say word list? That's goofy. Okay. I'm going to check word, and that's it, right? I can measure how long it takes to do this. Okay? And so that is
Really fast.
1/5000th of a second. No, 50,000th of a second. I don't really know how scientific notation works, and at this point I'm afraid to ask, right? We can check other things. We can check word in English words. Oh, and that is, folks, that is slower. That is quite a bit slower. So, naturally, as inherently inquisitive creatures, as I have understood that humans are, we should conduct an experiment. So I'm going to import time. I'm going to create a list of words. I'm going to create a list of 4 functions. I'm going to loop over the functions, and I'm going to loop over the words, and I'm going to time everything. Okay? And they're going to call it science, right? Y'all have heard of science.
Like the computer reminder.
It is, sure. There are computers involved. So I'm going to set this up. I'm going to import time, and then I'm going to run all of this shenanigans. So I'm going to put this at the end. What did I press? And then I have to write these functions: by in, by for, by copy, and by index. By index is fine. We already have that one. By index, by in, and that is return my word in English words. By for. Wait, what did I press? Okay. Never press tab. What are we going to do this? For word in English words, if word equals my word, hit him with the true. Otherwise, hit him with the false. Okay, so those should probably be about the same speed, right?
Right.
I thought they would. They're not, but that's okay. And then the last one is, we need to do the original version. So I'm going to go back. This is slide 16. Okay. Where is last class? There we go. And this is, I called it by copy. Okay. I don't know what to call this, but like this is the one where you're copying the list all the time. So I was like, oh, you do it by copying things. Like, I don't know. They can call it go and copy style. I'm in Shamboli. Do we want to look at any of this other stuff first? Oh, let me show you the test set. When I'm doing something like this where I'm hacking and I've got some code I want to use later, I could comment all that code out, or check this out. I just hit an exit right here, and I don't see anything else. So here's some things that are definitely words. Yarmul, Yellens, Zeisters, Wassailan, Wargals. These words are all made up. Oh, vivisected, that's a word. I know what that means.
Wassail?
Wait,
You don't wassail?
do you?
Oh,
I
all
feel
the
like-
time.
I wish I did.
That's a fake word. I'm looking it up right now.
It's like singing.
No, it's a drink.
No, it has something to do with apple trees and singing to the apple trees.
The tradition of wassailing, also spelled wassailing.
Visiting Wassail. See, I'm into something here.
This could be us.
It just could be.
It could be. It wouldn't even be that different than what we're doing now.
Field trip? Can we wassail?
No, I don't know how to do it.
I know the song "Here We Come a Wassailing" as the Christmas song my dad hates the most because it has really frequent time signature changes. So,
Oh, I get it. Time.
because
Doesn't get down around.
Yeah. Okay. Sorry. Yeah.
Because when we sing songs at Christmas, my dad is the one who's forced to play the guitar in the background. So.
We randomly selected racists, by the way. And also, I don't know if you saw it, trans was in here too. So if you randomly select 100 English words, you're just going to get some trans racists. Like, I don't know.
Are you recording?
One would hope not. Chat, don't clip that. Okay. Let's run this.
But on the other hand, you might get a wassail. And
You
that's
might.
Pretty cool.
Okay, so the for loop's not that much slower. But even the cringe copy version where you make a bunch of copies of all of the English words, that's still faster than Python in. And then the version that's good that I spent 2 days teaching you about is 1,000 times faster than the next best one. So if you've ever used a computer and it's been slow,
It's your fault.
well, it's someone's fault. I have never, to this day, I actually, one of the reasons I kind of got into computer science is, when I was but, a tiny skosh, a miniature human, a human smaller than adult humans, for example, I would press the button on what we now call the grandpa box, the desktop computer, right? And it would whir and, a fan would turn on. And then the screen wouldn't come on immediately. And I was like, it's a computer. What's it doing? I still don't know. Now I have a doctorate in computer science, and I'm just more annoyed than I used to be, right? So, never look into how computers work. It will only cause you to become more like me. Well, maybe that's an endorsement. Okay, so, is algorithmically efficient? Wait, no, we were on slide 16. Okay. Here's all of the code, by the way. I don't know that this is particularly, super visible on the screen, but you can click this button here, and it will take you to code that you can copy and run. I heard you not believing me. That's why I'm running this. Please work. That took longer to start because it was downloading English again, by the way. This is getting English through requests because it's on the internet, and I didn't want to assume you had English on your computer, okay? Oh, look, it's slowing down. Look, gaze. Yeah, gaze.
I don't know those guys.
They're not all guys. There's gays of all sorts.
Guys isn't gender neutral.
Okay. You can take that up with big feminist theory if you want. Okay. And then here's the link. Wow.
That's beautiful.
That is not what I expected the link to be to. Do not click that link.
It's like one of those poems where you
Why are there
You black it out.
Huh?
Why are there so many blobs in it?
something's wrong with it.
I don't know.
There's a lot of blobs in there.
It's blobular. All the blobs are after a new line. You see that? There's a new line right there. I don't know how visible this is. Okay, so blob, right? Blob detected. There's new lines in the blobs. See? So they're all supposed to be on new lines. So what we should do is we should take this. Hold on. I hear you all love going terminal style.
Alright.
I'm going to use 3 quotes. I'm going to print. Let's hope there's no little quotes in here. Oh, we were close. Is there a single quote in here somewhere? Oh, there's one right there. I have an ingenious plan. Well, I don't know why we're doing this. Okay. Okay. Grab the whole thing, right? Control C, okay. Control V. Whoa! Okay. Hit it with 3 quotes at the end. Okay. Now we're going to go back to the beginning. We're going to turn off word wrap. Okay. There we go. This is going to be S. Then we're going to print S. It's okay. Okay, this is what it's supposed to look like. That's actually like slightly more readable, right?
Sure.
It's okay. I find it quite readable. And then what should we do? We should see how many lines this is. 248 lines, I think. I don't know what this error means. That looks bad. Okay. I have a lot of tabs open. Let's bring it all together. Okay, so closing thoughts. Usually the built-in Python way is the fast way to do things. In the case of English words, because it's sorted, that's not true. Now, if English words were not sorted, you could still sort it. And it's possible you could sort the entire thing and then look things up this way and it would still be faster. Which we can test. Does anyone know how random.shuffle works?
No.
Okay, something happened. None type object is not subscript. Wait. No. That's on me. I think you just do this. Okay. Is it working? Okay. Now these other functions are going to explode because they're all assuming things are in order, right? They're just going to be wrong. But what you can do is we can time sorting it. Start equals time.time. English words dot sort print. What was it like? Sorting time? Question mark. Time.time minus start. That seems right. I didn't import time? Okay, that's how long it takes to sort the list. 0.05 seconds. So just always sort the list and then do the good code thing, because sorting is fast. Okay. What are we doing? Time. Okay. These are my reported results. Takeaway, if you know a list is sorted, you can be much faster than the built-in way of doing things. You can also, generally speaking, afford to sort the list and then do the fast thing. High-level takeaway, computer science is both a mathematical and a natural science. That's my claim. I think it's the only one. There might be another one someday. Probably not. computer science and experimental science is writing good code relevant announcements. Okay. Up next. Adventure. Okay. So you're going to be getting a valid choice on milestone 2. To me, it is not necessarily obvious how to solve this problem, so I have an example over here, and I'm going to show you how it works. Perhaps I forgot a comma. That's weird. That seems fine. Okay, so I want to do a demo first. We're going to imagine, in this case, that we have up to 2 choices, because I'm going to check to see that the number is less than 3. And what you're supposed to do in here is you're supposed to check to see if there's valid choices. So you're going to do cat, and that's not good. And then there's 5, not good. And then there's 1, that's allowed. And so I print out the 1 when you're done to see that it's allowed. I'm encouraging you to think about this in a specific way. So first of all, you might not be aware of s.isDigit, because even though I taught it in this class, it was like on a slide and I didn't talk about it and we never used it. So you might not know how to check to see if a string is a number. S.isDigit is a way to do that. And so we can say that is digit. It is, and I think like 12 isn't, right? So you can use that to check to see if something is a digit. Once you know if something is a digit, then you can do int on it. But you can't do that on 12. So you have to somehow check to see if something is a digit and then call int on it to turn it into a number. So my recommended way of doing that is when you get some input, check to see if it's a digit, and if it is, check to see if it's less than some value, and then you can return that. Okay. If you didn't know about isDigit, it shouldn't be that bad to figure out how you can check every character of a string to see if it is in 0 through 9. So that should not be that bad as well. I'm going to demonstrate you don't have to use isDigit. You can use the isNum that I just wrote, and this will work the same way. Cat 5.1. Okay. So, I don't really like this way of doing things, and I will point at, or I will highlight things that I don't like. I don't like setting something equal to none and then looping while it's not none and then updating that value. So instead, what we can recognize is that as long as we don't have a valid guess, the thing we're trying to do is getting a valid guess. So really, the only thing we have to do is return int s. And then we don't need any of this stuff. Is it Alt-Shift? That seems right. Backspace? Okay. But then what happens if we don't have a valid guess? So in this case, we say cat. Nope. Cat, and it doesn't work. But if we put in 1, it works. So if we do not enter a valid guess, what do we have to do? Well, you simply have to get a valid guess, and we already wrote the function that gets a valid guess. So you return getValid. And this behaves the same way. This is called recursion. And when I was taught recursion, because how this works is you write the function and then the function calls itself. The joke is always, in order to understand recursion, you must first understand recursion, right? I'm going to teach recursion more thoughtfully and completely on Monday, but I meant to teach it today. I was going to motivate time with it because where's the thing? You'll notice that that's the same structure. I can write this recursively. where you look in increasingly in small sections of the term, because I'm just keeping track of things outside of a loop. Right, so I'm going to write this recursively. And I believe in Python, recursive solutions actually are slower, so we'll find out if that's true on Monday. But I wanted you to see this because I thought it was so annoying to solve this with a while loop. I wanted you to see how to solve it recursively because it's not that many lines of code. Some of you are a little bit crazy, right? And you like doing things like short-circuiting logic operators. Do you remember this? When I wrote something like debug and print 7. And we found out, oh wait, do you have to capitalize? Have we been capitalizing Booleans all semester?
Yeah.
Okay.
Except in JSON.
Yeah, oh. Except in JSON. Okay. Not really a huge JSON fan. Oh, maybe I am. I like JSON well enough. So, what you can do is you can cause code after the AND statement to only run if the code before the AND statement is true. Are you all holding on to your hats?
Yes.
So held. That still works. You can put it on one line. You just have to put it in the right order. Cat 5.1. Okay. Stick with me here. If you change the order of this, it instantly explodes, okay? Can't do that, because you can't see what the integer representation of cat is. So you have to go the other way. But this one's allowed. Cat 5.1. Okay. Is there anything else I want to show? Yeah. I think that's it. Anyone have any questions about anything? All right. Enjoy having some number of days off. I'm not sure how many. I don't see you on Wednesday, right?
No.
Okay. Cool. I don't have any plans for Wednesday. If you want to hang out, we can hang out. But